This is an Equilibria question. It's working with KP, which you're likely to not have looked at until year 13. But it's got 4 sections, A through to D. I'm going to recommend you pause, try each section, work your way through the whole question, and then continue the video and review your answer. So starting with part A. Part B. Part C, and Part D. Okay, so taking a look at Part A to begin with, we know what the total pressure in the flask is, and we know the mole fraction of ammonia at equilibrium. So we're going to have to work out what the mole fractions are of the nitrogen and hydrogen so that we can then get to the partial pressures of all 3 of them. I'm going to start off with the most straightforward, and that is the ammonia. Because we know the mole fraction is 0.8, that means that 80% of that 150 kilopascals is being caused by ammonia. So I do the calculation and I find out that that means it's got a partial pressure of 120 kilopascals. Now, to do the remainder, I have got to look at the equation. I know that my nitrogen and hydrogen have a combined partial pressure of 30 kilopascals because that takes me up to the 150. But if 1 mole of nitrogen reacts with 3 moles of hydrogen, that means that however much ammonia I make, the ratio of nitrogen and hydrogen will remain 1 to 3. So from that, I can work out that the partial pressure of nitrogen is 7.5 kilopascals. That's 1/4 of the 30 remaining kilopascals. And I can do the similar calculation, or I can just add them up so they get to 150. The partial pressure of hydrogen is 22.75 kilopascals. Moving on to part B, and we want the expression for the equilibrium constant Kp for this reaction. So, jumping straight in, you'll notice that there are not square brackets on here, unlike Kc. Remember that square brackets means concentration in moles per decimeter cubed. If you include those in a Kp expression, you will not get the mark. Now, in terms of the powers, relatively straightforward. I've highlighted them anyway with the colours to see why NH3 is to the power of 2 and why H2 is cubed. It comes from the balancing of the equation. Okay, moving on to part C now, and I've included the expression of Kp here that you would obviously be looking back at to answer it. So here we want to calculate the value of the equilibrium constant Kp based on the partial pressures provided. Well, I already know what the expression is, so I now need to go through and put the numbers in. And once again, I've colour coordinated so you can see precisely why we've put each number where we have. That allows me to do what's a relatively straightforward calculation to get to my Kp value of 2.9 by 10 to the minus 3. In terms of the units, I've actually put in my kilopascals and multiplied them up. So on the top, I had kilopascal squared. So I've got kilopascal times kilopascal. And on the bottom, I had kilopascal and kilopascal cubed. So that's kilopascal to the power of 4. Now, I can very clearly see that I can cancel some of those out. So my units become 1 over kilopascal squared, but we want it in standard form. And that's why we get kilopascal to the minus 2. Moving on to part D. The enthalpy change for the reaction is negative 92 kilojoules per mole. What would be the effect of increasing temperature on the value of Kp? Now, we know that temperature will affect it because Kp, just like Kc, is temperature dependent. But I'm not actually going to say what the effect is until I've justified it, because it makes more sense to logically work through the process. The reaction is exothermic. I know that because delta H is negative. Now, that means that if I increase temperature, it will shift the equilibrium to the left. It's going to favour the endothermic reaction. It's going to favour, in this case therefore, the backward reaction. And that is to oppose the decrease in temperature. Now that means that Kp will decrease, and in red here you can see that what I've done is try to highlight why Kp would change in the way that it would. If the amount of reactants has gone up and the amount of product has gone down, you can see why Kp would be lower based on those changes to the numbers. If you're not sure on that, you might actually want to put some numbers in and then decrease and increase accordingly to see what Kp comes to, just to prove it.